Okay, this is the Unit 8 test study guide. Topic number 1 is simplifying rational expressions. Remember, we had a step-by-step to follow. Step 1 is factor everything that can be factored. Don't forget about GCFs. People forget about those all the time. So top, the numerator, we are going to work on a GCF first, and the GCF that we have there is a 6x. So without the 6x, this leaves a 2x behind, and then here we're left with a -5. So that's the numerator. Denominator, we're going to be starting with a GCF as well. They both have a 10 in common, also an x squared. So without the 10x squared, this is a 2x, and then this is a -5. So that's step 1, factor everything that can be factored. Step 2, simplify the monomials using exponent rules. So the monomials, the 6/10, for instance, are both even, so those can reduce down to 3/5, and then one of the x's can cancel, so this one's totally gone. This one leaves an x behind. Okay, so that's the monomials, because notice these are binomials. Step 3, eliminate common binomial factors. So only if they're identical or perfect opposites. All right, so these ones, we lose these. And then you can see what you have left over. So the numerator, all you have left behind is a 3. The denominator, you have a 5 and an x. So that would be your final answer for that first one. All right, we'll do it again for number 2 and 3. So step 1, factor everything that can be factored. So with the numerator, we're going to be starting with a GCF of 4. So you can take out this 4, and that leaves behind an a squared minus 9, which we can actually factor a little bit further. So we'll do that in just a moment. In the denominator, 24 and 8 have an 8 in common. So this is a 3 and then minus just an a. So top, let's work on that a squared minus 9. So that is the difference of squares, the a squared minus 9 is. So we have a -3, a +3, and then the denominator, nothing further to factor there, so that stays exactly the same. So we've got that. So now that everything is factored completely, we move on to step 2, which is simplifying the monomials. So the only monomials we have are the 4 and the 8. So those are numbers, and they can be reduced down. So divide each of them by 4. That leaves you with this. And then step 3 is eliminate common binomial factors. Now we don't have any that match perfectly, but we do have an a -3 and a 3 minus a. So since those are perfect opposites, we have something written in the notes where that's going to leave behind a -1. All right, so this reduces down to a -1. Don't leave the -1 in both spots, or that would be a -1 over -1, which is +1, and that's not right. So we've got a 1, a -1, and an a +3 left over. So that just means distribute the -1. So -a minus 3. And then in the denominator, all we have left behind is this 2. You could always leave the negative out front if you prefer. All right, number 3, step 1, factor everything that can be factored. So this top one, let's see, let's start with n times n, see if that factors normally. Multiplying to 40 and adding to a -13, that would be a -8 and -5. And then the denominator, there's a 3 in front of the n squared. So we're going to start by looking to see if anything is divisible by 3, and it's not, so we're going to do slide divide. All right, so I'm going to slide that 3 over and multiply it by the -5, and then we'll finish by factoring that. So multiply that 3, and then we'll factor that piece down. Okay, so factor this out the way that we normally would if that was just an n, and then we'll do the divide part. So multiply to a -15, add to a -14. That would be a -15 and a +1. Okay, so now finish the denominator by doing the divide. Okay, so divide and see what these reduce down to. So numerator hasn't changed, same factorization there. Denominator, remember if they reduce them. So this is now an n minus 5. And then if they don't turn into a whole number, then slide that back. So slide the 3 back in front of the n, like that. So now it's factored completely. Now go back to your steps. So step 2, simplify the monomials. We don't have any, so we don't have to do step 2. Step 3, eliminate common binomial factors. So n minus 5 and n minus 5. They're identical, so we can eliminate those. Okay, so now once those 2 steps are done, that means that this is simplified completely. Okay, topic number 2 is operations with rational expressions. So we've got multiplying, dividing, followed by adding and subtracting. Okay, so top one, number 4, that is a multiplication problem. So the way that you start those off, you either have monomials only or binomials and trinomials. Here we have binomials and trinomials. So we factor everything we can and then simplify. All right, so this one we're going to have a slide divide with that very first one. So we will start, sorry, no parentheses yet, ignore that. We will start by sliding the 6 over and multiplying that by the 5. We're also going to be doing a slide divide with the denominator since this does not reduce down by 2. So slide the 2 down there. This would be minus 18 times, this one is going to factor normally because it's just a p squared. So start with p times p. We are multiplying to 16, adding to 63, so that would be a positive 9 and a positive 7. And then the denominator looks like just a linear factor, but you do have a GCF that you can factor out. So you can factor out a 4, and then you have p plus 7 after you factor out that 4. All right, so let's work on the slide divides. So this top one, multiplying to 30 and adding to negative 13, would be a negative 10 and a negative 3. I'm going to leave a little space here so we can finish the divide part. This one, multiplying to negative 18 and adding to 17 would be a positive 18 and a negative 1. Okay, so let's finish these off really quickly before we write this one down again. So this one, finish off the slide divide by dividing by 6. This one, finish off the slide divide by dividing by 2. Okay, so let's rewrite that. So 10 over 6 reduces to 5 over 3, and then the 3 would slide back. This one, 3 over 6 reduces down to 1 over 2, and the 2 would slide back. Okay, and then this bottom one, 18 over 2 reduces to 9, so it stays. And then 1/2 does not reduce, so the 2 slides back. Okay, so now these ones, this guy right here is multiplying by this guy. So just visualize that they are right next to each other. So here we have a p plus 9 in the numerator, p plus 9 in the denominator, so those cancel. The p plus 7s cancel, and the 2p minus 1s cancel. So out of all the numerators, this 3p minus 5 is the only thing left. And out of all the denominators, this 4 is the only thing left. So that would be your final answer for number 4. All right, for number 5, we'll go through the exact same process. So top left here, I'm going to sneak in my GCF so you can factor out a 2. And so without the 2, we have 25 minus w squared. That'll save a little space. This one I can factor out a 3 from everything. So 3 comes out, and then I have w squared plus 3w minus 10. This top right does not have a GCF. Bottom right has a 6. Okay, so now without those GCFs, we can reduce them down. So this one, top left, we've got a 2, and then the 25 minus w squared, that's the difference of squares. That is a 5 minus w, 5 plus w. Bottom left, we have a 3 out front. This, when I factor this down, multiplying to a negative 10, adding to a positive 3, would be a positive 5 and a negative 2. Top rights, multiplying to negative 14, adding to 5 would be a positive 7 and a negative 2. And this bottom right is good as is. Okay, so that is completely simplified, so then we can go through and cancel out everything we can. So start with the monomials. So the 2 and 6 can reduce down to 1 over 3. Common misconception, you can't do anything with those 3's because they're being multiplied. All right, so then reduce down everything we can. So we have a 5 plus w. We have a w minus 2. And then we also have a 5 minus w and a w minus 5. So that's going to reduce down to a negative 1. Okay, so I'm sneaking that in there. So don't forget that negative 1. So we have negative 1 times a w minus 7, which is negative w minus 7. And in the denominator, we have a 3 and 3, which multiplies to 9. Okay, number 6, this one is division. So division, you flip and multiply by the reciprocal. We also are going to have some factoring that we need to do. So the 5y plus 5, we can factor out a 5, like that. The 2 is just a 2, and then we flip and multiply. So this, we're changing these so that we're multiplying by the reciprocal. So the 40y squared minus 32y. You can factor out an 8 and a y, and then that leaves you with a 5y minus 4. The numerator is now the denominator. These two have a 5 in common, so I can factor that out. And then after I divide each piece by 5, I have a 5y minus 4. So take out everything I can, start with the monomials. 5 and 5 can reduce down. 8 over 2, that divides down to 4. So that takes care of the monomials. Now binomials, you can cancel out anything that's perfectly matching. So the 5y minus 4s can eliminate. So let's see what we've got left over. We have a y plus 1 times the 4y, nothing left in the denominator. So I'm just going to distribute that 4y. So my answer ends up looking like this. Or you can have the 4y out front. So if you wanted to, you could leave it looking like this. All right, so let's look at number 7. We've got, looks like lots of GCFs here. So this top one, we have a GCF of 2. I'm going to start with that. Oops, sorry. Take out my GCF, so that should be a 2 there. Top right, I have a GCF of 16C. So there's just a C plus 3 left over. This one does not have a GCF, so I can start my slide divide. So slide the 4 over, multiply it by the 3. And this one's going to be the difference of squares. Okay, so let's carry on here. So the 2 is out front of my top left. Multiplying -3, adding to positive 2 would be C plus 3, C minus 1. Bottom left here, I can start, or continue on, I guess, with my slide divide. So start with C times C. Multiplying to a positive 12, adding to a -7 would be -3 and -4. And then finish it off by dividing by the 4. And then divided by, so this is where I multiply by the reciprocal. So here the 16c squared minus 9 is the difference of squares. That is a 4c minus 3, 4c plus 3, divided by this one, which is good to go. I just had to factor out a GCF. Okay, so let's see what we got here. So the monomials first, so 2 over 16 reduces down to 1 over 8. And then for my binomials, I have c plus 3 over c plus 3. I have, careful here, I think we should be good enough at slide divide. We recognize this. This is a c minus 1. This is also a c minus 1. This 4 would slide back here, and we'd have a 4c minus 3, which can cancel with this 4c minus 3. So if we look closely, I have a 4c plus 3 is my only thing left over in the numerator. Denominator, I have nothing here. I have an 8 and a c. Remember, this is a binomial, this is a monomial. You cannot try to cancel little pieces like that. Okay, number 8, we've got some subtraction, and this is a simpler one. You've got subtraction with a common base, so you're just going to be combining like terms. Be very careful with the subtraction. So 6x minus x ends up being a 5x, and then nothing minus -20 is a positive 20. My denominator is the common denominator, the x squared minus 16. Last step when you're doing addition and subtraction is to see if there's anything that can reduce down or simplify. So this in the numerator, I can factor out a 5, and that leaves me with an x plus 4. In the denominator, this is the difference of squares. So I have x minus 4x plus 4, and I can cancel out my common x plus 4. So my numerator is just a 5. My denominator is that binomial x minus 4. All right, number 9 is another subtraction example. This one, I do not have a common denominator. So what you do is you start by rewriting using a common denominator, and that process starts by factoring down any denominators that you have. So here a 3 can come out, and we have a k plus 5. So as of right now, they both have a 3, but this one has a k plus 5 that this one's going to need. So we are going to multiply top and bottom by a k plus 5. That way we'll get them set up as having the same denominator. Okay, so this, the 16, we can distribute the 16 to the k plus 5. So 16k plus, and then 5 times 16 is 80. When we're setting this up, just distribute the negative, so minus 4k minus 56, and that is going to be over our common denominator. So for right now, we're just going to leave the 3 out front just in case anything will factor and cancel. Okay, so combine like terms, 16k minus 4k is 12k, and 80 minus 56 would be 24. Okay, so the 3 stays out front. To see if we can simplify, that numerator has a 12 and a 24, so they're both divisible by 12. So I'm going to factor that out. And I'm left with this. So it looks like I can, if you look at the monomials, the 12 and 3, I can reduce those down. So 12 over 3 reduces down to 4. Okay, so distribute the 4 if you want. You don't have to if you don't want to. I'm going to. And then it will look like that. Okay, so let's look onto the next page. We've got some more of these, some more addition and subtraction with unlike denominators. So number 10, we are going to have an m squared, so this will factor down, m minus 9, m minus 1. So notice they both have an m minus 1, which means this guy needs an m minus 9. Okay, so now we would be able to combine them because they'll have the exact same denominator. So first denominator is m squared minus 7m minus 18, plus for the second denominator I need to distribute the 6. So 6m minus 54, and then over our common denominator. So I'll combine up what I can in that numerator. So I just have the 1m squared. Negative 7m, positive 6m would be negative m. And then my negative 18 and my negative 54, those would combine up to a negative 72. So that I'll be able to factor down, see if anything will cancel. All right, so let's look at that numerator. So multiplying to a negative 72 and adding to a negative 1 would be an m minus 9 and m plus 8. And you can see I have a matching binomial in that denominator that I'll be able to cancel out. So this just leaves me with m plus 8, m minus 1. Remember, you can't take pieces of binomials, just full binomials, so you could not do anything with those m's. All right, 11, another addition one with unlike denominators. So let's start by factoring. So 2r plus 1 doesn't factor. 4r squared minus 1 is the difference of squares. So that is 2r plus 1, 2r minus 1. So these match, but this one on the left is going to need a 2r minus 1. Okay, so we can rewrite that. So this distribute the r, so we will have 2r squared minus r, and then plus the rest of that on the other one over our common denominator. Okay, so this, combined like terms, I will have a 2r squared plus 11r and then minus 6. So that's everything combined in the numerator over my common denominator. Okay, so let's do a little side work for that numerator, see if we can factor that down. So this is going to require a little slide and divide. So slide the 2 over to multiply by the 6. Factor that down, we end up with r plus 12, r minus 1, and then divide the 2 back out like that. Okay, so let's see what we can rewrite this as. So 12 divided by 2 reduces down to 6. And then 1/2 does not reduce, so the 2 slides back out front. And you can see that is going to end up canceling with one that I had. So these will cancel, and then I just have these factors left over. Okay, 12, let's do one with monomials. So the 8a and the 24. Okay, so this one has an 8, this one has a 24, so the lowest you can go with is 24. So this one you're going to have to multiply by 3 over 3 to get the 24. This one has an a, so this one would need an a. So you're going to have to multiply by a over a. So now notice when you multiply these all out, they will both have a 24a as their denominator. So here, distribute the 3 to the a plus 4, and then multiply 5 times a. So that will be my numerator once I combine, and then I have the common 24a in the denominator. So here, add up my like terms, 3a and 5a, and then I'll be able to reduce these down, take out a GCF from the numerator. So 8 and 12 are both divisible by 4, so I can factor that out. And then the 4 I can reduce down with this 24 right here. So this is like reducing the monomials. So 4 and 24 are both divisible by 4. That leaves a 6 behind right here. So I have 2a plus 3 as my numerator, and then just a 6 as my denominator. Okay, 13, there's nothing to factor, but they're not the same denominator, so you just kind of multiply each one by the other one. So this one I need to multiply by h plus 5, and then the one on the right I need to multiply by h plus 2. Okay, so then they'll each have the same 2 pieces in the denominator. So on the left, distribute the 2 to the h plus 5. On the right, distribute the 5 to the h plus 2. And then over the common denominator, which for right now I'm just going to leave it in its factored form, like that. Combine like terms in my numerator, 2h and 5h is 7h, and then 10 plus 10 would be 20 over my common denominator. The numerator doesn't have a GCF or really anything else you can do, so it actually is just going to stay like that. You could FOIL the denominator if you want to, but there's really no need to do that. All right, 14, we have 3 different pieces that we're going to be combining up. So let's start by factoring this piece right here. These 2 pieces don't need to factor, but this will factor to x minus 1, x minus 3. So we're going to sneak in our extra multiplying here. So these ones have the denominator that they need. This one needs an x minus 3. This one needs an x minus 1. All right, so this one we're going to multiply by x minus 3, x minus 3. This one will multiply by x minus 1, x minus 1. Okay, so let's rewrite everything we've got here. So these 2, we're going to FOIL the x minus 3 times the 3x minus 1. So first we'll have 3x squared. Outside, x times negative 1. Inside, negative 3 times 3x. And last, negative 3 times negative 1. Next term, be very, very careful here because there is a negative. So I'm going to take this negative and distribute it. So change this to a positive and then distribute the negative to those 2 pieces for when you're foiling. So negative x times positive x would be a negative x squared. Negative x times negative 1 is a positive x. Positive 1 times positive x is another positive x. Positive 1 times negative 1 right here. And then our last one, nothing that we need to FOIL out for this numerator, so that is just an extra x plus 1. Okay, so lots to combine in that first piece. And then the denominator is just a common x minus 1, x minus 3. All right, so we'll combine like terms, that whole numerator, and then see if there's anything that can reduce down there. All right, so we have a 3x squared minus x squared, so that would be a 2x squared. For x's, we have a negative 1, negative 9, that's negative 10, plus x, so now we're at a negative 8, plus x again is a negative 7x. And our constants, we have a 3, minus 1 plus 1, so just 3. And over our common denominator. Okay, so let's check this out, see if we can do a slide divide. So this numerator, slide divide like that. Slide the 2 and multiply it by the 3. And this is x times x. To get the 6 and add up to a negative 7, we would have minus 6 minus 1, and then divide by the 2 to finally finish off that factoring. So the 6 over 2 reduces down to 3, and then the 1/2 does not reduce, so the 2 slides back over. So now we've got that numerator factored. Now divide it by what we have here. Okay, so the x minus 3's would cancel, and this would leave us with your final answer for that whole crazy problem. Okay, in topic 3, complex fractions. So there are a couple different versions. You've got one like number 15 where the numerator and denominator each only have one fraction already. And then problems like 17 and 18 where each numerator or denominator have two separate pieces. So you just have an additional step with those. They end up being basically the same. All right, so step 1, to create a single fraction in the numerator and the denominator like I was just talking about. So with number 15, that one is ready to go. 16 is halfway there. So for 15, we get to skip over step 1 right on to step 2. Step 2 is to set up like a division problem. So you're multiplying by the reciprocal. So it's this whole numerator divided by this whole denominator. So we set that up as multiplying by the reciprocal. Okay, times, and then you flip this. So we have the m squared plus 7m minus 18 in the numerator, and then the 3m cubed minus 6m squared in the denominator. Okay, so that was step 2. Step 3, simplify. So that step says factor first if possible. Some of them you might be able to use, some of them you might not. So this one, we have the 12m cubed is a monomial, so that one is just going to stay the way it is. This denominator here is just regular factoring, so you start with m times m, and we are multiplying to 45 and adding to 14, so that would be 9 and 5. So that's that one. Top right here, we start with m times m again. We are multiplying to a negative 18 and adding to 7, so that would be a positive 9 and a negative 2. And then this one in the denominator, these have a GCF. You can take out a 3m squared, and then without it, we have an m for the first term and a negative 2 for the second. Okay, so then this is basically just like what we were doing in the last topic, where you have either multiplication or division, and you start with the monomials and then cancel any common binomials. So these are the only monomials here. The 12 over 3 can reduce down to 4. And then the m cubed, m squared, we have 2 common copies that can cancel, leaves you with an m behind in the numerator. And then identical binomials, so m plus 9, m plus 9, m minus 2, m minus 2. And so this leaves behind a 4m in the numerator, and then an m plus 5 in the denominator. Remember, nothing can happen with those m's, because one is part of a monomial, one is part of a binomial. All right, 16. Same 3 steps. Step 1, make sure you only have a single fraction, numerator and denominator. So the numerator is fine. The denominator needs to get cleaned up. So what we're going to do with that is make sure that these can have a common denominator so that they can be combined up. So this, you can get a common denominator of 6. So you're going to multiply by 2 over 2 for this one and 3 over 3 for this one. Okay, so let's write that as multiplication by the reciprocal. So here's that numerator, and then times the reciprocal of the denominator. Oops, sorry, let me turn that off. So this one we are going to flip. So this denominator is going to end up being 6, so that will flip. And then this, when I combine these up, I have 2k plus 3. So it used to be the numerator, but then it flips to the denominator like that. Okay, so that was step 2, is to set up as a division problem, multiply by the reciprocal. Step 3 is that we are going to factor and then simplify each one of these pieces. So top left, we can take out a GCF of 4, and then we have 2k plus 3 left over. 9 is just a monomial, so is 6, and 2k plus 3 is not factorable. So step 1, monomials. So we have 4 over 9, which doesn't reduce. 6 over 9 does, though. So reduce it down by a factor of 3, and we're left with that. Once the monomials are reduced, move to the binomials. You can eliminate any common binomials, so that would be these. All right, so numerator, we end up with 2 times 4, which is just 8, and then the denominator is just a 3. So this actually just reduces down to a normal, fraction, rational value like that. 17, we have to start with that first step where we get just one fraction, top and bottom. So the top here, we have a 2 and a b, so our LCD would be 2b. Common denominators. This one multiplied by b over b. This one multiplied by 2 over 2. We have to do the same thing in the denominator here. Since this one has a b and this one technically has a 1, that means that b will work as the common denominator. So that 1 we can write as b over b. All right, so let's rewrite it after combining everything. So this one, b times b is a b squared minus 32 times 2 is 64. That we'll be able to factor in the next step over our common denominator of 2b. So that's the numerator. Divided by, now let's do this for the denominator, b times 1 plus 8. Can't combine that, so we just leave it like this. Over our common denominator of b. So that was step 1, making sure you just have one term, top and bottom. So the next is to write it as a multiplication problem. So we're going to do that. So b squared minus 64 over 2b, multiply by the reciprocal, so b over b plus 8. And then the last thing to do is to simplify, cancel, get our final answer. So top left, you can factor difference of squares, b minus 8, b plus 8. Denominator is just a monomial. This numerator is just a monomial, and b plus 8 does not factor. So when we simplify, we start with the monomials. So b and 2b, there's a b that can cancel out. And then eliminate any common binomials, which would be the b plus 8s. Okay, so our numerator just has a b minus 8. The denominator actually just has a 2. Okay, one more of these type. Number 18, we have to combine, get a common denominator so that we can get one fraction at the top, one fraction in the bottom. So this one, x plus 1 we need, and x we need. So x plus 1, this guy needs to be multiplied by x plus 1, and then this guy needs to be multiplied by x. Okay, this one you can factor out a 3. Neither one of these were factorable, by the way. So this one you can factor out a 3, and then you can see there's an x plus 1. So this one already has the 3, so it needs an x plus 1. Okay, so this one's going to be a little bit more complicated than the ones that we had before. Just kind of focus separately on the numerator versus denominator, and then we'll turn it into a division problem. So this, we've got in this numerator, x times x is x squared plus, and then distribute the 4 to the x plus 1, like that. And then our common denominator is x times x plus 1. Overall denominator, all this down here. So the 4x plus 7 doesn't change. Here we have a negative 1 to distribute to this x plus 1. So we have negative x, negative 1 over our common denominator. Okay, so a lot going on with that one. This numerator right here, 4x minus x is 3. And then we have 7 minus 1, which is 6. All right, so I'm going to write it as a division problem. So x squared plus 4x plus 4 over its denominator, which is x times x plus 1. And then we are multiplying by the reciprocal of this part. So the reciprocal flips the 3 times x plus 1 to the top. And we simplify this. 4x minus x is 3x. 7 minus 1 is 6. So that's where we're at when we flip and multiply. Last thing is to factor and then cancel anything that's common. So top left, regular factoring, multiplying to 4 and adding to 4 would be x plus 2 over this, which is already factored down, times top right is already factored down as well. We just need bottom right. So this you can take out a 3. When you take out a 3, you have an x plus 2 left behind. So start with the monomials. The 3, the x, those are monomials. These 3's can cancel. Nothing changes with that x. And then the last step with reducing and simplifying is to cancel out any perfectly common binomials. So either one of these x plus 2's can cancel with this one, and then the x plus 1's would cancel. So the numerator just has an x plus 2. The denominator just has an x. Remember, those x's cannot and will not cancel. And then moving to topic 4. This is application stuff. So this is the multiplication and the addition just under the topic of geometry, basically. So number 19, we are looking for the area of a rectangle. First thing I would recommend doing is just making sure that you know those formulas. So the area of a rectangle is length times width, and then you've got these things measured on here. So it gives you the area, and then you're kind of working its way backwards to the width. All right, so we have the length right here times the width equals some value that we've got right here. All right, so we have, if we know, let's see, if we want to solve for width, the way that I would recommend doing this is taking the width and getting it by itself by dividing both sides by L. So we would know that width is area divided by length, just using this formula right here and getting the W by itself. So in this way, we know the area, we know the length, we can set it up in what will turn out to be a complex fraction. Okay, so the width is the area, which is this beautiful expression right here, divided by the length, which is this one right here. And this turns into a complex fraction that we were literally just working on. All right, so for each one of these, we want to get a common denominator. So this one, the n and the 2, the only possible common denominator would be 2n. So this one we're going to use n over n. This one we're going to use 2 over 2. 4n and 2n squared. So common between 4 and 2 would be 4. Common between n and n squared would be n squared. So we want them each to have a denominator of 4n squared. So this one needs an extra n, and this one needs an extra 2. And then they'll both have a 4n squared. Okay, so let's rewrite this. So this one, distribute the 2, we will have 2n minus 6 plus 7n over our new common denominator of 2n. That's the numerator. We can still simplify that up just a little. This one, n times 3 minus 1 times 2 over our common 4n squared. Okay, so that's step one with the complex fractions, is to get them to each just have one piece, numerator and denominator. Then we would turn it into a multiplication problem. So this, the 2n and 7n would be 9n. So I have 9n minus 6 over 2n, and then multiplied by the reciprocal of this. So the 4n squared flips, trades with the 3n minus 2, and then you simplify. So this now turns into a multiplication problem where you factor, reduce the monomials, cancel any common binomials. So the only thing I see to factor here is the 9n minus 6. You can take out a common 3, and then this is what it leaves you with. And then everything else is either a monomial or is not able to be factored. So monomials first. So 4n squared, 3, and 2n, those are our monomials. So the 4n squared divided by 2n reduces down to leave a 2n behind. And then common binomials can cancel. So this, the 3 and the 2n would just be 6n. So it actually ended up being a pretty simple expression for that width. All right, number 20, the volume of a rectangular prism. Volume of a prism is length times width times height. So I'm taking all three of those expressions and just multiplying them together. It doesn't really matter which one you choose to be the length, width, and height. I would call this the length, this the width, and this the height, but obviously it's not going to change a thing. So we have the length times the width times the height. I'm going to factor them as I'm writing them down. So the length, the x squared plus 13x plus 42. We have x times x to give us the x squared. Multiplying to 42 and adding to 13 would be plus 6 plus 7 over this, which is a monomial, so it doesn't factor any further, times the width. The numerator is a monomial, so it doesn't factor. The denominator has a GCF, so I can take out a 5, and after I divide by 5, it leaves me with x plus 7. Times the height is this, so the numerator, x squared minus 9, that is a difference of squares. And the denominator here, the x squared, I start with x times x, and multiplying to a negative 18, adding to a positive 3. That would be a positive 6 and a negative 3. Okay, so start with the monomials. We have a 3x, a 6x squared, and a 5. Those are the only monomials. So 3 over 6 reduces down to 1 over 2, and then x over x squared reduces down to 1 over x. Okay, and then last step to simplifying is any common binomials can cancel out. Okay, so look across the numerator. We have an x plus 3 left over, and then the denominator, we have a 2, an x, and a 5, so that would be a 10x. Remember, nothing can happen with those x's because you can't just take a piece of the binomial without the whole thing. And 21, the perimeter of a triangle. Perimeters are super easy. You're just adding the three sides together. So it would be like A plus B plus C. So just adding all three of these pieces. All right, so let's take C over C plus 5 plus 4 over C minus 5 plus, and then this one I am going to factor the denominator down because it's the difference of squares. So C squared minus 25 is C plus 5, C minus 5. So you can see since it's perimeter, I'm adding, and since it's addition, I need to make sure that I can get the same denominator for all my pieces so that I can add them. So my denominator, these two pieces have a C plus 5, these have a C minus 5, which means that these two pieces are going to be the common denominator. So this piece needs to be multiplied by a C minus 5, top and bottom. And this one needs a C plus 5, top and bottom. Then that way, if you look across, I have the exact same denominator for all three of these pieces. So I can combine them into one big fraction, see what I can do to combine like terms. So here, distribute the C. I'll have C squared minus 5C. This one, distribute the 4. And this one didn't have any changes, so this numerator just stays. And then the denominator is that factored C minus 5, C plus 5. So let's combine like terms in this numerator. This is the only C squared. For C, I have negative 5, positive 4, and positive 7, and that would be 6 when I add them all up, 6C. And for the constant, positive 20, negative 15 would be a 5. And this denominator is just staying the way it is until I get through my next step. So next step is to factor that numerator if I can. So to multiply to a 5 and add to a 6 in the middle, that would be a positive 5 and a positive 1. And you can see there I have a matching binomial that I am able to cancel. So these common binomials can cancel, and this leftover expression would be my final answer for the perimeter. Okay, and then topic 5, we've got solving rational equations. There are two methods. One is to solve it like it was a proportion, and that's really more applicable to a problem like 22 where you only have one fraction on each side. And then method 2 is you could use an LCD. You can use the proportion method even in a case like this, but you would have to combine the left-hand side, for example, into just one fraction before you use the method. So I like to just keep it where if it's already just one on each side, do the proportion. If you have more than one on each side, use the LCD method, but it's truly up to you. So number 22, we are going to solve using a proportion. So we can cross multiply each way. So cross multiply these two together. We have a minus 8 times a plus 5 equals, and then multiply this way together, a times 3, we've got a 3a. So that one we're going to end up foiling the left-hand side together and then cleaning the whole thing up. So we have a times a, which is a squared. Outside we have a 5a, inside we have a negative 8a, so 5 and negative 8 would be a negative 3, and then the last is negative 8 times positive 5, which is a negative 40. All right, so we have this 3a on the right. Since it's a quadratic, it means you want to get everything on one side, and then you'll solve it by factoring. So we're going to subtract the 3a from both sides. So this is a negative 3a. When I subtract 3a, I get negative 6a, and I can solve it by factoring. So for my a squared, I start off with a times a, and then the negative 40, if I'm supposed to be multiplying a negative 40 and adding to negative 6, that would be a negative 10 and a positive 4. Okay, so solving these can set each piece equal to 0. So if I set a minus 10 equal to 0, I can add 10 to both sides, and I get a positive 10. This, I subtract 4 from both sides, and I get negative 4. So with our rational equations, you want to make sure that the denominators are not going to be 0. So 10, 10 plus 5, not 0, so this one's good. Negative 4 plus 5, neither one of those is 0, so that's good. So write them as a solution set. Numerically, you'd have the negative 4 first, followed by the 10. So that's your answer for 23. For 22. For number 23, you want to use the other method where we look for an LCD. So this denominator is 2n, n squared, 2n squared. So this denominator actually covers all of them. So what I mentioned during the actual section, I would just pick each piece. So like 2n, you want a 2n to cancel, you make sure there's a 2n here. N squared, if you want an n squared to cancel, you make sure there's another copy of n, and then 2n squared is already exactly what you have right here. So you're going to multiply everything by 2n squared. So you can either like distribute that into the numerator and then work on canceling, or you can just cancel the numerator first, whatever works best for you. So this one, the 2n squared over 2n, there's an n left behind to multiply by that 3. So we have a 3n plus this one, the n squared cancels the n squared. There's a 2 left behind to multiply by the 1 equals, and on this side, the 2n squareds cancel, and you just have an n minus 2 left behind. So this is a pretty basic equation to solve when it comes down to it. Start by subtracting n from both sides. So 3n minus n is 2n. And there's a negative 2 left on the right. Subtract this 2 from both sides. So the 2n is left alone. Negative 2 minus 2 is negative 4. And then you solve by dividing both sides by 2. So the n is by itself. Negative 4 divided by 2 is negative 2. And just confirm if you plug in a negative 2 here, or here, or here, just make sure that it's not going to be 0. And it won't be. So this answer is good, and we can write it in our solution set form, like that. All right, let's look at our next page. We've got 2 more of this topic. So 24 is our next one. This one, same thing, we've got separate pieces, so we can't do the proportion. You want to factor this left-hand piece down, that denominator, so that we see what pieces we need for our LCD. So p times p, multiplying to a positive 6, adding to a negative 7, so that would be negative 6, negative 1. Remember my method I mentioned, you just want to take the whole thing and make sure you're multiplying every single piece that you would need. So you would need the p minus 6 to cancel. You would need the p minus 1 to cancel. This p minus 1 will already cancel, and then you need a 3. So throw a 3 in there as well. Okay, so let's see what gets left behind after I multiply everything out. So we've got p minus 6 will cancel, p minus 1 will cancel. There's a 3 left behind to multiply to this whole expression. So I will be distributing that 3 to this whole expression like that. Next one, there's a p minus 1 that will cancel, and then there's a 2 times a 3 times a p minus 6. Okay, so 2 times 3 is 6. Distribute that to the p minus 6, and we get this. Equals, and then on the other side, you've got a 3 that will cancel, and then there's a 2 to distribute to the p minus 6, p minus 1. So p times p is p squared. Multiply that by a 2. Outside, negative 1p, negative 6p, so that's a negative 7p. Distribute the 2. And last, 6 times 1 is 6. Distribute the 2, we get 12. Okay, so we're sneaking that in there. Okay, so that is what we end up with. We want to combine like terms, solve that equation. So left-hand side, we have 3p squared. For p's, we have a 9p. Constants, we end up with a negative 12. And then right-hand side, there's actually nothing to combine. We're just going to move everything over to the left. So subtract everything over. Move everything to the left so that our right-hand side will just be 0. So 3p squared minus 2p squared is p squared. 9p minus negative 14p ends up being 23p. And negative 12 minus 12 is a negative 24. So that's what I have on the left. This is my last step. I'll end up factoring that down. So for p squared, I start with p times p equals 0. I need to multiply to a negative 24 and add to a positive 23. So that would be a positive 24 and a negative 1. All right, so set each of those equal to 0. P plus 24 equals 0. If I subtract 24 from each side, I get this. P minus 1 equals 0. If I add 1 to both sides, I get this. All right, so plug your values in. So negative 24, negative 24 minus 6, negative 24 minus 1, negative 24 minus 1. No zeros there, so that one's fine. When I sub in the 1, 1 minus 6, 1 minus 1. So 1 minus 1 is 0. This ends up being an extraneous solution. So when I go to list any possible answers, I only have the negative 24 because my other answer gave me a denominator of 0. A denominator of 0 is undefined, so that one did not actually work out. It was an extraneous solution. All right, last one of these is 25. So 3 doesn't factor, 4v plus 3 doesn't factor. For 12v plus 9, I can factor out a 3. And then that leaves behind a 4v plus 3. So you can see these two pieces are going to be my LCD. So my LCD needs a 3 and a 4v plus 3 to make everything cancel out. So just kind of double check that each piece will cancel. If everything will cancel, then you chose the correct LCD. That's how that works. So here we've got 3 times 3, or 3 over 3 will cancel, and there's 1 times 4v plus 3. Minus the 4v plus 3's will cancel, and we have 1 times 3 left over. Equals, and then my last piece here, that whole denominator will cancel. So I just have the numerator. Okay, so this is a quadratic. I want to make sure I get everything on one side, so I'm going to stick with this side. So I'll subtract everything over. So there's no v squared to subtract. I have a negative 3v minus 4v, which is a negative 7v. And this actually just ends up being 0. So just the negative 18 stays right here. So factor that right-hand side. So v times v is v squared. We want these extra constants to multiply to a negative 18 and add to a negative 7. So that would be a negative 9 and a positive 2. So set each one of these equal to 0. So if I set v minus 9 equal to 0, I add 9 to both sides. And here if I set v plus 2 equal to 0, I subtract 2 from both sides. So double check you won't get 0 in the denominator. So 9, 4 times 9 plus 3, not 0. 12 times 9 plus 9, not 0. Negative 2 times 4 plus 3 is not 0. Neither is 12 times negative 2 plus 9. So both of those solutions end up working out. So I have 2 answers for number 25. Okay, next, topic 6, we are graphing rational functions. So we have 2 different types. We have the reciprocal functions and then just the generic rational functions. So the reciprocal, the way we identify those is that the numerator of the rational piece is always just a constant. Okay, so constant, constant, not a constant. So these top 2 are the reciprocal functions, the rest of them are not. So the reciprocal functions, you use the vertical asymptote, the horizontal asymptote, and then you plot a couple points to figure out what the shape of the graph is going to be. All right, so the vertical asymptote, initially it's 0, but if there's any shift left and right, the asymptote will move with it. So this x plus 4 tells you that your whole graph is shifting 4 units to the left. So if you shift 4 units to the left, it is going to shift that vertical asymptote 4 units to the left as well. So that would be this right here. Okay, so that's what that shift does. Shift up and down. Initially, the horizontal asymptote is y equals 0. This minus 7 means your whole graph is shifting down 7 units. So it moves the asymptote with it. So 1, 2, 3, 4, 5, 6, 7. Okay, so that's what you set up with. Now you want to know just to the left and right of the asymptote, what are your points going to be? So just the left would be a negative 5. So let's do that. So negative 5 plus 4 is negative 1. 1 over negative 1 is negative 1. Minus 7 would be negative 8. Okay, so you have a point right there. So that means it's going to be this little scoop kitty corner to the intersection. And then you could also plug in negative 3, so just to the right of the line. So negative 3 plus 4 is 1. 1 over 1 minus 7 would be negative 6. So you'll be in that little kitty corner. So the way I like to graph them, kind of go along the vertical asymptote, so you hit the point, and then along the horizontal asymptote, and then do the same thing in the other direction. So your graph should look like that. Domain and range are super easy in this chapter. You just exclude any of the asymptotes, and then in the next section, any of the holes as well. So the domain is any x value except this value right here. So anything but a negative 4. And the range is very similar, anything but a negative 7. Okay, something really similar for number 27. Start with the vertical asymptote. The default is that it's at x equals 0. unless it moves left or right. So since this is just an x, there actually is no shift left or right, so this is just a 0. So that would be right down the y-axis right here. Horizontal asymptote is initially 0, but it can shift up or down. So this +3 moves the whole graph up 3 units. So that is going to move the horizontal asymptote up 3 units as well. So that would end up right here. Okay, so this is x equals 0. So go 1 to the left, 1 to the right, so you can see what the picture looks like. So 1 to the left is a -1. So -2 over -1 is +2, plus 3 would be 5. So that point is right here. And then I could plug in a +1, so -2 over +1 is -2, plus 3 is 1. So that point would be right there. So along the vertical asymptote till I get this point, and then glide along the other direction, and same thing here. Okay, so domain just excludes the dotted line, so no 0. Range just excludes the dotted line, so no 3. So those are the reciprocal functions. The rest of them are just kind of generic rational functions. So you've got a step-by-step to follow there as well. It's a little bit different, and it's nice because over on the side I've got a list of all of the things that you need to include. So that's basically a step-by-step for you right there. First step, if you need to though, is to simplify the function. So you may need to factor and cancel. These don't factor because they're just linear functions, so you jump right to the next step. And the next step is the X-Intercept. So you take the numerator, whatever that expression is, and you set that equal to 0. And that's how you find the X-Intercepts. So let me label that for you. So here we can subtract 5 from both sides. So when I do, I end up with a -5. And make sure you're writing it down as an ordered pair. So for an X-intercept, the y-coordinate is always 0. So that would be 1, 2, 3, 4, 5. Got a point right there. For the vertical asymptote, you take the expression from the denominator and set that equal to 0. That becomes a dotted line. So here I subtract 2 from both sides, so I get a -2. So that is written as an x equals line, just like they were up here. So that would be this dotted line. Horizontal asymptote, this is the tricky set of rules. It's based on the degree of the numerator versus the degree of the denominator. So here, x over x, they both have degrees of 1. So if the degrees match, you're looking at the leading term. So 1 over 1 reduces down to 1. So our horizontal asymptote has a value of 1. That would be this line right here. Okay, a hole only happens if you factor and cancel, so there is no hole in this graph at all. Okay, so if you want, you could take a quick glance at a graphing calculator or use Desmos just to get an idea of what the shape of that graph is going to look like, plot a couple points. We know this side is going to go like this. And then if you were to plug anything into your calculator, you end up with kind of a mirror image right here. Okay, so domain, anything but the vertical asymptote and any holes. So there's no holes, so it's just excluding the vertical asymptote. And range is just excluding the horizontal asymptote. Okay, so that's the first one. I've got a few more of these on the next page. So number 29 would be next. So same multi-step process here. First step, remember, look to see if it can be simplified. So simplifying means factoring and canceling. So here we can take out an x, a GCF. Here in the denominator, we can take out a 2 as a GCF. And notice here that you can cancel out this common factor, the x plus 6. So you end up with just x over 2. So it's going to be a pretty straightforward function to deal with. So our x-intercepts, you take whatever's in the numerator, and you set that equal to 0. So you end up with 0 as your x-coordinate, and you know 0 is your y-coordinate for an x-intercepts. For a vertical asymptote, you take whatever is in the denominator and you set it equal to 0. 2 doesn't equal 0, so that means that there is no vertical asymptote. The horizontal asymptote, you compare the degrees. This one has a degree of 1. This one technically has a degree of 0. So if it's a bigger degree in the numerator, that means that there is no horizontal asymptote. So we do not have that either. The whole is an ordered pair, an xy coordinate point. So we are looking at the canceled factor, actually, the x plus 6. So for the whole, you take the canceled factor and you set that equal to 0. That gives you the x coordinate anyway. So here I can subtract 6 from both sides and I end up with a -6. So that is going to be the x coordinate. And then for the y coordinate, you take what you get and you plug it into the simplified version. So x over 2 becomes -6 over 2. And that reduces down to a -3. So you've got this right here. So let's write down what we have. So 0, 0 is our x-intercept, also happens to be our y-intercept. And then this says that we have a whole at -6, -3. So 2, 4, 6, and then down 3. So plot that as a whole. This x over 2 is actually just a linear function. It's the same really as 1/2 x. So it's a line that goes through the origin and has a slope of 1/2. All right, so you really just have to connect these dots, make a line out of it, and that's all there is to it. Remember, every once in a while, these end up being a line with a hole. The domain is anything except for that hole. And same thing with the range, except the y value this time. Okay, so that is number 29. Number 30, we're going to start again by seeing if there's anything that we can factor and cancel. So the numerator, x squared, we start with x times x. We are looking to multiply to 24 and add to a -11. So to do that, to multiply to a 24, we should have 2 negatives. So it ends up being a -8 and a -3. And then the denominator is the difference of squares. So x minus 3, x plus 3. So here we cancel out this x minus 3, and it reduces down to x minus 8 over x plus 3. So follow our process here, starting with the x-intercepts. For the x-intercept, you take whatever's in the numerator, and you set that equal to 0. So if I take that, I would add 8 to both sides, and I end up with x equals 8. And remember, that's just the x-coordinate for an ordered pair. The y-coordinate would be 0. So that would be this point right here. For the vertical asymptote, you take whatever expression is in the denominator, and you take that and set that equal to 0. So here I can subtract 3 from both sides, and I get -3. So remember, vertical asymptote is always an x equals line. So over at -3, like that. The horizontal asymptote, you take the degrees and compare them. So first degree, if they're the same, you do the ratio, of their coefficients. So 1 over 1, of course, is 1. So that is our horizontal asymptote here. The whole, you have a whole if you canceled something out, so that means we do here. So for the whole, you take the canceled factor and set that equal to 0. So I can add 3 to both sides. So I get 3 as the x-coordinate. And then for the y-coordinate, you take that x value and you plug it into what you have after you reduce. So the y-coordinate, plug in 3. So we have 3 minus 8 over 3 plus 3. So the 3 minus 8, we end up with a -5, and then over 6. It's just a nice little fraction value there. So 3, so 1, 2, 3, and then -5, 6. So just above 1, you'll have a hole right there. All right, so connect the dots. We use our asymptotes to kind of come along here, glide through these points like that, leave a hole right there, and then this one ends up being like the little kitty corner opposite spot here. But again, any assistance, feel free to use Desmos or a graphing calculator. Domain, you exclude the vertical asymptote as well as the value of the whole, the x value. It's like that, positive and -3. For the range, you exclude the horizontal asymptote as well as the value of the whole. Okay, one more graph. So same thing, simplify, see if anything can cancel. So the 3x plus 3, you can factor out a GCF, and that leaves you with an x plus 1. For this, we're going to do a little bit of side work here. So we're going to slide divide the 2. So x squared plus 9x plus 14. So multiplying to 14 and adding to 9 would be 7 and 2. And then we can simplify this by dividing back out that 2. All right, so now we're ready. So 7 over 2 does not reduce, so we slide the 2 back. and 2 over 2 reduces down to 1. So this would be x plus 1. So just like the last couple have, we've got one factor that will cancel, so that's going to turn into a whole. So now let's go through our step-by-step process over here. So for the X-Intercepts, you take the numerator, which is 3, and you set that equal to 0. Obviously, they're both numbers, and they're not equal, so that means there is no X-Intercepts. For my vertical asymptote, I take the expression from the denominator, and I set that equal to 0. So I subtract 7, and then divide both sides by 2. So when you divide both sides by 2, you end up with negative 7 halves. And negative 7 halves is the same as negative 3.5. In case that makes it easier for you to plot. So negative 7 halves, which is the same as negative 3.5. So we go 1, 2, 3.5. It'll look like that. Horizontal asymptote, you compare the degree of the numerator to the degree of the denominator. 3 is just a constant, so it has a degree of 0. 2x to the first is a degree of 1. So 0 versus 1, the numerator is smaller. And anytime the numerator has a smaller degree, the horizontal asymptote is just 0. So that would be this line right here. Okay, and then a whole. You get the whole by seeing what you canceled out. We canceled out an x plus 1. So for the x, you take that canceled factor and set it equal to 0. So we can subtract 1 from both sides, so we know that's going to be the x-coordinate. And then you take that value and sub it into the simplified version, so 3 over 2x plus 1. So when I sub the 2 in here, I have 2 times negative 1 plus 7. So it ends up being a 5, negative 2 plus 7. So we get 3/5 as the y-coordinate for our whole. So negative 1, and then up at 3/5, so just, put a hole right there. All right, so we can use this right here, goes through, and you can see the reason why we don't have an x-intercept is because the x-axis ended up being our asymptote. So we're not actually going to cross that x-axis. And then we have this shape right here. All right, domain. Exclude our whole as well as our vertical asymptote, like that. And for the range, that was terrible, there we go. Exclude the horizontal asymptote as well as the value of the whole. Okay, then 32 and 33, just a couple quick ones here, creating a function. So 32, we have a reciprocal function, so we know the numerator is just going to be a constant. It's translated 8 left and 3 up. They don't mention anything about reflecting or compressing or stretching, so that means the numerator is just a 1. 8 left would mean that you have an x plus 8 in the denominator like that, and then 3 up would mean you have a positive 3 off to the side, like that. Asymptotes are pretty easy just based on these descriptions right here. So if you're shifting 8 units left, the asymptote would shift 8 units left over to a negative 8. And then the horizontal asymptote, if you shift 3 units up, the asymptote shifts up to a positive 3. All right, number 33, last one. So we can use the way that we solved all of these and kind of piece together this information. So we have an x-intercept at negative 1, 0. So notice the way that we've been finding the x-intercepts, whatever this value is. So if you have like an x minus 8, you get an 8. If you have just an x, you get a 0. So if the intercept is negative 1, that means our numerator must have been an x plus 1. And then we can see what you would have in the denominator. So I'm going to write our function notation. And then vertical asymptotes at positive 7 and negative 5. The way we find vertical asymptotes is by taking whatever's in the denominator and setting that equal to 0. So if I have x equals positive 7, that means I would have had an x minus 7 in the denominator, and another one at negative 5, so I would have had an x plus 5 in the denominator. Okay, and then it also says to, well, let's simplify it actually, get that denominator factored out. So foiled out. Positive 5x, negative 7x, that would be a negative 2x, and then last, negative 7 times positive 5. So that's what the actual function would be. You normally see it in that form, not its factored form. And then identify the horizontal asymptote. So x to the first has a degree of 1, x to the second has a degree of 2. The numerator has a smaller degree than the denominator, so just like 31. Anytime that the numerator has a smaller degree, the horizontal asymptote is just automatically 0. And then on the next page, our last topic is variation. So topic 7, we've got direct, joint, and inverse variation. So let's get these formulas on here so we can use them. So our direct variation, we have y equals k times x. Joint variation, we have y equals k times x times z. And then our inverse variation, we have y equals k over x. All right, so first you guys are just practicing setting up what an equation would look like before you sub things in. So 34, s varies jointly with. So normally when you see this one first, that's the one that's by itself. And then jointly means the k gets multiplied jointly with t cubed and v. So you'd set it up like that. Number 35, we have m varies, so that's the one that's by itself, just like the y is up here. Inversely, so you've got the k is always in the numerator. N squared is the inverse one, so that one gets divided, and then directly with p, so that means the p gets multiplied by the k. So sorry, that's a second power right there that kind of got blended in with the p. All right, it's 36, 37, 38. We are determining just what type of variation it is and identifying what k is there. So number 36, this one's a little sneaky because the 3 is on the wrong side of the equation, so we would divide it over to the right to get the y by itself. So it'd be a 1/3 on the right once it gets divided over. So with the y by itself, we have 2 variables that are multiplied, so that would be a joint variation, and in that variation, the constant is 1/3. Make sure you simplify that first. This one, we could really go either way. It kind of depends on which one we want to be the variable by itself. Let's say just since the d is on the left side of the equation, that we want the d to be by itself. So if we multiply both sides by 2, we get 2r. Since the variable is multiplied and there's only one variable that is direct, and the constant there is a 2. That's what's multiplied by the r. This one is a little bit tricky too. We want to get the y by itself, I would say. So a couple different ways to do this. You could cross multiply, do a little proportion. So let's say we cross multiply here, we get x times y. Cross multiply 8 times 6, we get 48. So to get the y by itself like we're used to, we would have to divide both sides by x. So the 48 would get divided by x. So you can see once that's simplified a little bit, it is now set up like inverse variation. And once that's set up, the constant is in the numerator. So that would be 48. All right, so none of these were just handed directly to you. You had to do a little bit of work to figure out what type of variation it was. All right, so 4 of these examples and then we are done. So these ones are a little bit more direct. These ones are your story problems. So number 39, we start with w varies directly as r cubed and inversely as s. So that's your setup. Just kind of reading that first sentence and doing a little bit of practice here allows you to set up your equation, sub in the first set of values so you can figure out what k is. So we have w is 24 when r is 4 and s is 8. Okay, so we use that to solve for k, and then once we find k, we can actually answer the question. So this 4 cubed is 64, and 64 divided by 8 is 8. So we have 8k. So this 24 equals 8k. If I divide both sides of the equation by 8, 24 divided by 8 is 3. So that gives me the value of k. Then I can sub that into this equation along with the value of w and the value of s. So I have w equals k times r cubed, so that's what I'm solving for, and s is 27. Okay, so let's reduce the 3 over 27. 3 over 27 reduces to 1 over 9. and then I am going to multiply the 9 to the other side of the equation. So 81 times 9 ends up being 729 equals r cubed. And then to solve for r, we would take the cube root. So this is one of the values that you guys had way back in your list of perfect squares and cubes and fourths. So the cubed roots of 729 ends up being 9. So I get r equals 9 for this one. Okay, let's do something very similar for number 40. So b varies jointly with a and c. So we have that set up. They give us the first set of information, so we can use that to solve k. So b equals 112, when a is 12 and c is 7. Okay, so we can use that, solve for k. So 12 times 7 is 84. So we divide both sides by 84 to get a value of k. Okay, so I think we're just going to go with a decimal here. So just to show you my screen, 112 divided by 84, we get 1.3 repeating. So 1.3 repeating we know is 4/3. That actually might be a better way, just to stick with the fraction, make sure our next answer turns out exact. So now we know k, we want to solve for a, we know b, we know c. So back into this same equation, b is 72, k is 4/3, we don't know a, we know that c is 2. All right, so 4/3 times 2 is 8/3, and we're solving for a. So to get a by itself, we want to multiply by the reciprocal, both sides, which would be 3/8. Okay, so here we get a by itself. So let's see what a is. So 72 divided by 8 is 9. 9 times 3 is 27. Okay, so just two more here. These are your story problem types. We have the wind force F varies jointly as the area and the square of wind speed. So let's see. Wind force varies jointly as the area of the sail and the square of the wind speed. So like that. So that's your setup. So basically you're doing just what you did with problems like up above, except it's got a little context behind it. So the force with an area of 500 feet is 64.8 pounds when the wind speed is 18. So we use all that information to solve for k first. So the force is 64.8 pounds when the area is 500 feet squared and the wind speed is 18 miles per hour. So we sub that all in. So let's get a nice little decimal here. So to get k by itself, we're going to be taking 64.8 and we're going to be dividing it by 500 times 18 squared. So we get 0.0004. So all those decimals are very important. So k is 0.0004. That's going to help us get a nice accurate answer for the rest of this. So this is what would be the force. So we're solving for F for a sail with an area of 250 feet. So we now know that k is 0.0004. The area is 250 feet, and the wind speed is 35. And remember, in the formula, that gets squared. So we can just sub this in. So 0.0004 times 250 for A times 35 squared. So we get 122.5, and then make sure you include units because this is something that has a context behind it, and the force is given in pounds. So this would be 122.5 pounds. All right, last one. So you've got volume of a gas varies directly as the temperature and inversely, so a combination here. So volume varies directly as the temperature and inversely as the pressure P. So that's your setup. We have an initial set of information that we can use to solve for K. So at a temperature of 200, so that's T, pressure of 500, that's P, the volume is 240. So let's solve all that in. So 240 is V. We do not know K. The temperature is 200, and then the pressure is 500. So we sub all that in. We're solving for K. So we're going to multiply by the reciprocal here. So we have 240. We're going to multiply by the reciprocal of this fraction right here. So 500 over 200. And so this ends up being 600. So that's your value of K, is 600. And we can use that in the next equation to solve. So we are going to set up, it says find the volume of the gas, so V equals. We now know that K is 600 times T. So this is a temperature of 275. And pressure is the inverse variation. We're subbing that in as 400. So just take that numerical expression, sub it in, and we'll get volume. So we have 600 times 275 divided by a pressure of 400. And that reduces down to 412.5. So that's your volume. And our volume here, it gave us centimeters cubed, so you would use the exact same units.